So in the previous example, we learned how to use hydronium ion concentration to find pH, or how to use pH to find the hydronium ion concentration. Well, in this example, they introduced something new. They introduced the concept of pOH. But the idea of pOH is the exact same thing as the pH. A pOH scale, analogous to the pH scale, can be devised by using the negative log of the hydroxide ion concentration of a solution. So just like we use the negative log of the hydronium ion concentration to find pH, well, we can use the negative log of the hydroxide ion concentration to find pOH. We could also take the pOH, the antilog of the pOH equation, to find the hydroxide ion concentration, just like we did here in the previous example to find the hydronium ion concentration. So consider with me just for a second, consider the ion product constant for water at 25 degrees Celsius. Y'all remember when we wrote that equilibrium constant expression for the autoionization of water? It was this times this is equal to the ion product constant, which has a value of 1.0 times 10 to the minus 14. Now, if I take the negative log of both sides, this is how the text derived what we're going to use to answer these example problems. If you take the negative log of both sides, you end up with this. Okay? Now, from the definition of pH, how did we define pH up here? pH is equal to the negative log of the hydronium ion concentration. Well, look, that's what this is right there. So what is the negative log of the hydronium ion concentration? pH. What is the negative log of the hydroxide ion concentration? pOH. That's what we define there. What is the negative log of 1.0 times 10 to the minus 14? 14. And so what we have is that the pH plus the pOH of a solution is going to be equal to 14. So since we know that, we can determine either the pH from a given pOH, or we can determine the pOH from a given pH using this equation right here. So now let's apply it. We have a solution at 25 degrees Celsius that has a pH of 6.15. Now the reason they are giving you this temperature of 25 degrees Celsius is because the ion product constant of water, Kw, is dependent on temperature. So at 25 degrees Celsius, it's 1.0 times 10 to the minus 14, which when we did the math, the negative log of that gives us 14. So the temperature does matter. That's why they give it to us here. And they want us to find the pOH. Well, let's use the formula that we just derived. pH plus pOH is equal to 14. They give us the pH, so we'll list that as a given, 6.15. We are not given the pOH. But I know that the pH plus the pOH of the solution should be equal to 14. So to find the pOH, I just rearrange this equation. pOH is equal to 14 minus the pH. So the pOH is equal to 14 minus 6.15, which gives me a pOH of 7.85. Is this two significant digits? Yes, because I have two decimal places, and this is my answer.